In this video I'm going to explain to you how to derive the equation ns equals c over cs. So if you look into your textbooks on page 190 of the AQA physics course, we've got this figure that you can see on the screen now, and what we're going to do is we're going to use this figure throughout this derivation in order to help us understand what is going on. So as we can see in this figure, at this point here, point x, we've got the light ray entering the medium. Okay, it's going to travel down this way. And at this point y, it's going to be travelling through the air still, and go down to this point there. And now we can work out the distance travelled by each of them by using the equation that distance, d equals speed times time. Okay, so x to x prime is going to equal cs, which is the speed in the substance multiplied by time. Our distance y to y prime is going to equal just ordinary speed in air or vacuum multiplied by time. Now if we consider this triangle at the bottom here, for this part here which I just highlighted, and we're going to use the equation that sine theta equals opposite over hypotenuse, you'll notice that this part here is your opposite, and this part here is your hypotenuse. From that then, we get that sine r equals CST over xy prime. Now if we consider the other triangle, which is this one around here, what we're going to use is the same equation again, but this time we're going to get an expression that sine I, which is this bit here, I, that's your opposite, and that's your hypotenuse, is equal to CT over xy prime. Now I want to rearrange both these equations so that we can get CT as a subject. So rearranging this one will give me CT equals xy prime sine I. I'm rearranging the equation I've got in the red to get CST. CST equals xy prime sine r. Now I'm going to use both these equations going forward onto the next slide. Now I want to combine both these equations. I find the easiest way to do that is to divide one by the other. So I'm going to put one divide sign in there, and we're going to have the blue one on the top. So CT equals xy prime sine I. We're dividing that by CST equaling xy prime sine r. You can see that those will cancel, the times will cancel, and we're left with the equation that C over CS equals sine I over sine r. So now we're going to use this equation moving forward onto the next slide. So now we've got the expression that sine I over sine r is equal to the speed of light in air compared to over the speed of light in the glass. What we need to look at now is how we relate that to n. So if you remember rightly, ns is equal to sine I over sine r, so long as it's coming from a air into glass, where the refractive index of air is 1. So if we combine those two equations, we can see, I'll put this in red, that ns replaces a sine I, that's equal to ns, and that will equal c over cs. So we've proven that the refractive index of the substance is the speed of light in air divided by the speed of light in that substance. That's the derivation we need to do.